Okay, so thank you everyone to be here, and thank you to the PyCon Lithuania organizer for the invitation. And before to start, let me to say thank you also to Sab and Shub for the support and all the support team. So I am Mauro, and also thank you for your beautiful pronunciation of my name. And today I will speak about data warehouse and data lake. And they seems very old concept, but I will tell you our journey of one European project of 11 years now. And I will try to explain to you how these concepts are not so old and why we needed to continue to speak about data warehouse and data lakes during the architecture of our data platform. So, in my presentation, I will go in detail. I will start from the result. So I will present this project that we are doing with my colleagues at European level, and currently we scale this project at the global level. And we are speaking about a project where we are handling more or less 500 terabytes of compressed textual data, so a bunch of data, to try to inform our policymaker inside the European Union at the local level, but also at the global level, about the evolution of the labor market. And of course, I will use this project to try to explain to you how we organize the data inside the project to try to inform not technical people, because when we speak with a politician, when we speak with policymaker, of course we need to remind that they cannot use data. Okay, they are really able to maybe they are really able to apply policy, to create policies for us, to try to create more good jobs, but definitely they are not able to use the data. They are not statistician, they are not a data scientist, they are not a technical user. So what we need is to try to create data warehouse where the data are consistent, are not noised, to try to inform them about the evolution. And of course, I will use my experience inside these two projects from Eurostat. I don't know if you know, Eurostat is the European organization that aggregate all the national statistical institute from the European Union. And these two organizations, CEDEFOP and ETF, are two European agencies, are not so famous, so permit me to explain a little what they are doing. CEDEFOP is based in Thessaloniki, in Greece, and their scope is to try to organize, to try to plan the next vocational training for the job seeker, for our student, inside the European organization. ETF, European Training Foundation, more or less do the same in external European countries. So I'm working for CEDEFOP for the European countries, and for ETF for countries like Ukraine, Georgia, Morocco, Tunisia, and Algeria, to try to improve the jobs in this country. And what we are doing is try to create real-time labor market information system. I will explain in a few minutes what mean and why it's correlated to data warehouse and data lakes. I'm also a teacher in University of Milano Bicocca and University of Bergamo. I'm from Italy, and I teach big data analytics. Okay, so something related to the scope of today. If you want to have the slide of today, are public and are present at this GitHub repository. So it's quite easy to find it. You don't need to be worried. Everything is public. Here you have also my contact. So if you have any question about the project, about the presentation, and also about data, generally speaking, you can write me or you can contact me in LinkedIn. So let me to start from the result of my journey. The result of my journey is this real-time labor market information system of skill requirement. So quite a long title, sorry. But few keywords. Labor market and real-time, that are two keywords that are in opposite, or at least 20 years ago when I started my career, they were in opposite. Because I don't know if you know, but the labor market data at European level or global level are updated every year, so not real time. Okay, skill requirement would mean that what the policymaker need are detailed data about the skill requested by the employer, and of course real time. So what we tried to change starting 10 years ago, creating a data platform, was a platform that in real time can inform our policymaker, our university, about the real skill need. And of course, we started from the context. currently the list is not exhaustive because every year I'm adding a new topic. We started 11 years ago about the digital skill because everyone was speaking about the digital skill, but everyone doesn't know nothing about the digital skill. And of course, we added some skill, internationalization, a new profession, the Ukrainian war, the COVID-19, and now artificial intelligence. What is the result? The result that the data that we had 10 years ago were not enough to explain the evolution of the labor market, and we need more fresh data. And we started to pass from official statistics that are good, relevant, of course well-structured, with big data. Big data because what our stakeholder requested was real-time data, real-time and detailed data. And of course, we found them inside the online job posting data. Online job posting data used in different way across the different countries. Of course, we have more data in US, in Australia, in Germany than in Georgia, but it not mean that the data are not good. And of course, what we need is to collect this data in real time because we are speaking about web pages with a lot of noise, and we need to translate them in analytics, easy to use, ready for our policymaker. And of course, this is easy, it seems easy on a slide, but it's not so easy because if I watch only the last 10 years, inside the European Union, we are speaking about 1 billion of web pages downloaded, more than 32 countries to be monitored, from the big countries like UK, Germany, France, to the small country like Malta. And of course, we need to find a way to harmonize the data across the different countries and more than 9,000 different sources. So we have a lot of number, and if I think about this 1 billion, if we watch globally, we are more or less at 3 billion of online job posting collected, but we are using the 20% of this data. Because of course, what our stakeholder need, again, is not a bunch of data, but are inside. This is a public tool, you can use it, you can navigate to the QR code, which a lot of data already ready to use in dashboard. So of course, we are speaking about 1 billion of data with a lot of different dimensions organized, a lot of money spent, but then finally we have few data. So as you can see, are more or less 100 data points. So nothing, okay? Why? Because of course, when we collect data from the web, we have a lot of noise. This is the main architecture of the system at the height level. Of course, we have different sources that provide data in different quality. We apply different techniques to try to collect data. Web scraping is the main one, but also in some cases, we have a direct connection with the sources. We apply pre-processing techniques to remove the noise. The noise from the online data is about the 80%. So we cannot use the data from the 80% of the totally that we are collecting. We apply model, AI model, from 20 years old model up to latest model to try to create a data warehouse. And of course, before we store everything, because currently maybe it's noise, but in the future we don't know if it is noise or not noise. I need to give you a story. Before the 2020, no one was looking for the share of remote posting online. So the share of the online job posting that requested or permit the remote working. Currently, everyone is looking for it. So we don't know the answer, the question from our stakeholder of tomorrow. And of course, it's important here to store everything in the data lake. So in the next part of my presentation, I will go in detail about this journey because here we have a lot of features like the consistency, the quality, the data are not changing, so are stored, and if we query the system today or tomorrow, we will have the same answer because of course what our policymaker need is the consistency in the data to create policy, and here we have a lot of data not structured, where we try to extract new insight. And of course, this is we need to do it because this is the format of one online job posting data. We have something that is really structured. Here we have a job location, London. Sorry, I took one in English to try to be good for everyone. We have the contract. We have the occupation here. But of course, then we have a bunch of information about the skill, which is the more important part. This is here, and a lot of noise. This one. And of course, we need to remove the noise for now to try to mark the structured data and the structured, because what we need is to try to extract the insight and normalize them using AI models. So what are the main challenges during this journey? Of course, we are in a multi-language environment. My US colleagues are not happy about it because their language is only English, but in Europe we have a bunch of different languages. I don't know if you know, but we are speaking more than 35 different languages in Europe, from English, of course, to Basque, the Basque language, the Catalan language, the Galician, and all the languages are important because we are in Europe. We have data coming from the web, so a lot of noise that currently is noise, but we don't know in the future. We need to try to translate them in standard, because of course when a policymaker, when a teacher access to the data warehouse, need to navigate the data of Germany, France, Italy with the same taxonomy. And of course, it's not something that we did in 1 year. This is, I try to summarize the journey from 2014 to last year in this chart. Is not so good, but as you can see, we started a lot of years ago to collect data, and currently with the latest AI model, we are going really more fast, because currently it's more easy to find a good model to process the data and to apply the data to the data stored since 2014. This is another message that I would like to leave to you. So store the data, maintain the data in the raw format, because I think you know very well, this is the gold. Currently, what we are doing here is apply the latest model available to all the data historically, because we can find a new insight, we can extract a new insight. So let me to leave for 1 second the labor market context to speak about data warehouse and data lakes. And I am Italian, okay, and I love the food, so I will start from the type of cake. I took this one from a very popular talk of Cookier from the TEDx of 2014, which is a normal question that we can have from our stakeholder in one retail chain, in one food industry. So what is the America favorite type of cake? And everyone knows from books, from TV series, that is the apple pie. Okay, why we know it? Because if we watch the data, we know that the more sell cake type of cake in US is of course apple pie. We started to collect retail sales data from Walmart, Tesco, Lidl, I don't know, and so on. We try to apply ETL, and we created a data warehouse to try to answer to our marketing and sales team and give them some insight about the most favorite type of cake. And of course, you know very well that this is the classical BI process, business intelligence process. So when I speak to my economic student in university, I start usually from this slide, because of course we need to remember ourselves as data engineer, data scientist, data analyst, that we need to collect data according to the question that we need to answer. Okay, and of course, if you need to understand what is the more solid type of cake in America, I will start to collect the more available data, the more easy data to be collected, that is the retail sales data. I will apply some ETL process to try to clean the data, prepare the data for the analysis. I will provide them to our sales department, and then the user will use the data to make a decision. It is a very important point. If I watch to the Solomon definition from 2008, so a lot of years ago currently about data, but it is quite good. It is inside this paper about the BI process. Of course, is the process. So it is a process that starts from the collection of the data, that store the data ready for the analytics, but finally the user will use this data. I will insist on this information. When we need to organize the platform with the data warehouse and the data lake, we need to remember that the process will end when the user will use it. Okay, and of course, our scope as data engineer, as a scientist, is to prepare the data to be used by the user. If not, the process will fail and the entire project will fail. And of course, what we did to try to reply to this question was to apply the BI process. We started to identify the source system, so the system of Walmart, Tesco, Lidl, and so on. We identify the information that we collect it. We store the data in a data warehouse. We provide the data, and then we think about the application. And of course, this is good because we apply the classical top-down approach. Okay, when I started 11 years ago about the labor market, the real-time labor market information system, I applied this type of approach. I started from the question. The question was, what are the more diffused digital skills? What are the more diffused digital occupation? What is the impact of the digital skill for the education system? And I try to identify the more relevant sources, online data, online job posting data, and then I try to find the confirmation from the data about this digitalization of the labor market. But of course, we have another approach, that is the bottom-up approach. Okay, what mean? Collect everything and then understand what we have inside the data. Of course, this is really more expensive. Because if I return to my question, I didn't ask you what is the more relevant type of data inside the retail sales data. But the question, what is the favorite type of cake? But it's a different question. Of course, if I use retail sales data, it's a good proxy about favorite, but it's not the same. Okay? And of course, if I apply a bottom-up approach, I can find new sources to try to answer to new questions. Of course, I can use social media data, I can use data from, I don't know, Reddit, from a forum, from a sensor, and so on, to try to find the more favorite type of cake. And of course, inside this journey, I am applying a bottom-up approach because I don't know nothing about the final question. Maybe I will find that apple pie is not the favorite America's type of cake. Maybe I will find something else if I don't use retail sales data. So it's really important to try to store everything and then arrive to the final question. Let me to give you two definitions, because of course we need this type of object, data warehouse, for our final user. The data in the data warehouse are integrated, so they speak the same language. If I watch my project, I can navigate German data as well French, as well Italian, with the same taxonomy, because what we did it was to create integration and harmonization inside the data. Of course, data warehouse is subject-oriented, so my data warehouse is for labor market and skill. I cannot understand the type of contract, for example. Okay, because what we did is try to create the data warehouse to try to answer to the question about the skills, because the project was a skill requirement. Of course, the data warehouse has a scope about the time. We update it every month, and of course is non-volatile. What I mean? If I answer the number of digital skill requested last year, today, tomorrow, yesterday, the answer is the same. This is really important to do it. But of course, we need another object, that is the data lake, okay? Where we try to store everything, we try to apply new model in real time to arrive to fast question, because the labor market as well, our phenomenon, currently are evolving in real time, and we cannot wait 1 month for each question, and we cannot use the same structure of 5 years ago, because of course, the market is completely different. So we need a system that is machine learning ready. So permit to our data scientists to apply new model in real time. We need access to the raw data. So we need a way for the analyst to access to the text and information and extract new insight. We need a way to store the data with a schema-free approach and permit rapid change. So, of course, this is more challenging than a data warehouse, because in a data warehouse, we need something that is consistent. We need a system where we can measure the data quality. In the data lake, is completely different. And of course, one way to do it is to organize the system inside the different silos. So what we did is to separate the system in mainly 4 parts. The data ingestion in real time that collect the data and then pass the data throughout a queue inside the pre-processing where we apply different type of model in parallel to try to extract the insight with different taxonomy, with a different type of application. And then we merge the data. And when we merge the data, we consider only the last 4 months of data. It's a long story about the last 4 months, but it's due the duration of the online posting online, okay? And then we store the data every day inside the data lake. What means that the data lake is updated with raw data and classified data every day with the latest version, and here only data expert can access. What means that data expert, data scientist, statistician can access with a new question to this object. But the final user, policymaker, citizen, decision maker can access to this object because the data, of course, are more noised. And then every month we update the data warehouse. What means that we update the data warehouse with the classical dimension about the skill and with a new insight coming from these people. And before to move the data here, we apply rules. What mean rules? We apply standard rules every month to try to detect particular noise, particular issue about the quality. And these rules are defined from a team that is outside my team. Okay, so we have an external team that defines the rule about structure, format, distribution, and if we have an issue here, we stop the release of the data because, of course, policymaker can make the wrong decision. Okay, if the data are not in quality to be released. As you can see, we have 1, 2, 3 part and 4 with the ingestion. Okay, every single part has a different scope and we apply different model to try to track the final result. And of course, we apply a bunch of different AI models, from models that are quite old, models that are more updated, and we continue to update the different model. Let me to speak a little about the format of the data. Of course, we are using both in data lake and in both data warehouse or columnar data format, but we apply different type and different library. The main 3 that we are using are data.io, that is coming from Databricks, of course, because we are on a Spark environment. We use it inside the data warehouse because we need a way to update the data. We need upsert and delete operation, okay, inside the data warehouse. We need a fast way to access. Our entire ecosystem is based on AWS cloud environment, and data.io is good to be queried also by environment like Athena, for example. The second library that we are using is Apache UD inside the data lake. Why? Because Apache UD is more structured, is more good when we have large batch operation. And we need a way every day to update 4 months of data to try to create this big merge and to update the latest 4 months. So UD with its particular structure on the operation, of course, it is well integrated with Athena and the AWS ecosystem, is really good for this type of large batch operation. We also evaluated another library, but we are not using it in the system, is Iceberg. It's coming from Uber, is quite good. I'm only leaving you one word, one keyword about this library, is not dependency from Apache Spark. You know that Apache Spark could be defined as the standard de facto about data processing. If you are not using Apache Spark, maybe Iceberg could be a good choice, also because it's well structured where you need a night concurrency inside the data. For example, you cannot use Spark, data.io and UDI if you are in a system where you need high concurrency. Inside the presentation, you will find also some benchmark coming from paper about the performance of update, insert and delete of these free libraries. It's not updated, but it's valid. It is of 2 years ago. And you will find a recap about the main feature of the library. Of course, for example, if you need the scheme evolution, Apache Iceberg and UDI are maybe the best, and Delta Lake not. If you are on a Spark environment, I recommend to use Delta Lake for everything, but of course then it depends about the workload. One of our suggestion, of course, is to watch the number of commit, the number of PR, and of course, as you can see, we are speaking about well-supported library. So, thank you everyone, and if you have any question, I'm here.
Yeah, coming.
At the beginning of your presentation, you said that you use 20% of the data that you ingest. Can we talk about operating costs versus return on investment?
Yes. So, why we are using only the 20% of the data? Because one of the big issues that we have with the online data, generally speaking, and in particular with the online job posting data, but it's true also with the social profile, it's true also for other type of online data, is the multiplication of pages. What means that you can arrive to the same page from different sources. Okay, if you think about social profile, maybe everyone, you have one LinkedIn profile, one X or Twitter profile, Facebook, Instagram, GitHub, and it is the same for the online posting. You can find the same posting on, I don't know, Indeed, LinkedIn, our local platform, and from the employer. So the main issue that we have is to identify this duplication to arrive to the unique job posting. More or less, we remove the 70% of the data for this duplication. It is an issue. It is a pro because if one posting is present on multiple platform is another metric. About the operation cost, of course, what we try to do is to minimize the cost, and we put the duplication, the remove noise at the beginning. So it's not impact a lot for the rest of the process because we apply it at the beginning and we detect this noise, we store it, so it's a cost about the storage, but you know that you can have some techniques on the cloud to reduce the class of the storage and reduce the cost, but then we don't apply models if the data are duplicated. The real noise, so the phenomenon of the ghost posting is less than 5%, so is acceptable.
All right, we can do one last question and then we move to the next one.
Hey, so I wanted to ask, did you have any obstacles with GDPR or storing the data that's sensitive, and where does it happen? In warehouse, in lake, or where?
Yes, good question, thank you. Yes, we have GDPR issue. In particular, of course, so we collect social profile and the online posting, and we have the issue on both because inside the posting you can have name, surname, email, and telephone, and we apply a GDPR detector, GDPR removal during the ingestion because we cannot circulate the data with the personal information. So, so when we download the page, we apply before store the page the name detector, telephone detector, and blah 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 to remove directly the information, and we store the data with no personal information. Which is the scope. Then the system is accurate up to 98%, so something is remaining, but you know.